Hi and welcome to Unit 2 Topic 2 Video 15, and this is our last video on identities within this trig topic, and we're kind of scraping at the barrel of relevance here. Because this is the far end, you won't see these ones come up quite as much. So let's have a look at what we know and then what we can transfer that to. So we know that cos of A plus B is equal to cos A cos B plus sin A sin B, and that's on a formula sheet, and an equivalent one for cos A minus B. So then we can also get cos of A plus B plus cos of A minus B. I'm just going to do this addition here, and hopefully you see that these guys cancel each other out, leaving us with 2 cos A cos B. That's a bad B. And that means, of course, that cos A cos B can be written as a half cos of A plus B plus cos of A minus B, or perhaps the expanded form. Now it turns out that cos A cos B can be written as a half of cos A minus B plus cos A plus B. And sin A sin B can be written as, and sin A cos B can be written as, cos A cos sin B can be written as. Interestingly here, if we do a little swapperoo with the A and B, well, 3 and 4 are kind of the same in a lot of ways, and you should see that come out in their formula as well. So 4 isn't really necessary. The other good news is, though, that they're on the formula sheet. So you need to memorise them, but you do need to know that if you've got a situation where you've got, say, sine of 15 times sine of 75, or maybe you can use one of these to simplify it down to more doable situations. So I'll leave that one with you. Now, we do have to add to this. Can we determine a representation for cos A cos B? That's the next question. And the answer is yes, we can. We're going to talk about how to do this. So whereas the previous one, the development was quite simple, in this one the development's a little bit harder. So I'm going to shoot across to the side with my blue pen and do a little bit of work first, because I'm going to build an understanding of cos A cos B, but from this format here. Well, I've kind of got cos A cos B, but I don't. I've actually got cos A minus B and cos A plus B. Okay, so over on the side here in pink, I'm going to say, well, what if we let A equal x plus y and B equal x minus y? Now, a little bit later on, it's going to be important that I go through the process of showing that A equals x plus y can be transferred to be x equals A minus y, which can be put into this to get B is equal to A minus y, and when rearranged that gives me A minus B is equal to 2y, which means that y is equal to A minus B over 2. And then if y is equal to A minus B over 2, then I get, and my working's a little bit poor here, so I apologise, but x is equal to A minus B over 2, and that can be simplified to be A plus B over 2. So I've got an x and a y value, which I'll need a little bit later. Something's happened to my b over here. So cos of A plus cos of B. That's what we're trying to simplify. Now, I'm going to write this down as cos of x plus y plus cos of x minus y. And we'll see what that's equal to. If we shoot back up here, well, we've got a bit of an understanding about cos of x plus y and cos of x minus y here and here. That's equal to 2 cos of A cos of B, but we swap the a's and b's for x and y. So this is equal to 2 cos x cos y. So that's all good and well. And I'm going to follow this through now. Our cos of x plus y plus cos of x minus y equals that, which means that it's equal to 2 cos, our x we've got as A plus B over 2, and then our y we've got as A minus B over 2. And so therefore we can now say that cos of A plus B, cos of B, is equal to 2 cos A plus B over 2 times cos of A minus B over 2. That's a pretty bald B again. And so if we shoot down here, we get exactly that. But again, we get 4 variations. So this is the one we just proved. Okay, it's not a big proof. Involves just being a little bit clever about the use of X, Y, just to build our way there. But it is a pretty complex proof in terms of making the right decisions. But we can do the same thing in 3 other cases. Now, these aren't on the formula sheet, but they are dropped in places. So it's important that you recognise they're there, and also recognise that whilst they're not on the formula sheet, look how close they are to something that is on the formula sheet, i.e. these formulas here. So I would be sticking to just practicing using the formulas above, but you have this representation available now too. So that's the end of the video. I'm going to go through some examples in the subsequent 3 videos, which you might want to hang around and watch. All the best.